Okay, good afternoon, everyone. This is your 8th station in solid waste management course. Today, we will have one question that is relevant to leachate production from a landfill site. And this will be a little bit long question, so I strongly recommend you to listen carefully. And let's start with the question by reading detail. According to the question, we have a landfill facility where leachate is produced, and we will calculate the amount of leachate produced from this facility for 2 years. And moreover, in the question, the information about the amount of waste deposited per different time intervals and the characteristic of waste are listed. And then the data that shows the landfill characteristic and rainfall amount are given. For example, lift heights, the ratio between lift to cover material specific weight, gas production details, and the PF capacity formula are listed within the scope of landfill characteristic. In the solution of this question, first we should define the components of water balance for the only lift one, and you can see the relevant sketch of this problem in the left-hand side of the slide. And to estimate the weight of cover material and solid waste, we should use a specific weight of them and the height information. For example, if we multiply the specific weight of soil, or let's say cover material, and the height of the cover and the leachate production area, we can calculate the weight of cover material as 1,666.7 pounds. And here, to find the height of cover material, we can use the cover to lift ratio information given in the question. And according to this ratio, we can say that if the height of cover is equal to x, the overall height will be 6x. So the remaining, or 5x, belongs to the height of cell or the solid waste. And also the number of 3 in this equation comes from the unit conversion to feet from yard. And then with the similar procedure, we can calculate the weight of solid waste in the lift one as 2,777.8 pounds. And this time, 1,000 in this equation comes from the specific weight of solid waste. And as I explained before, the ratio of 5/6 comes from the, again, cover to lift ratio given in the question. And then we can find the total weight of the lift as 4,444.5 pounds by adding the weight of cover material and the solid waste. And then the moisture amount inside the solid waste can be calculated as multiplying the total weight of solid waste that we have calculated before with 0.2, or the moisture content information reported in the question. And therefore, we can say that moisture amount of solid waste is equal to 555.6 pounds. And the remaining part represents the dry weight of solid waste. And to find this amount, we can either subtract the moisture amount from the total weight or multiply the dry content ratio, or 0.8, with the total weight of solid waste. And then to calculate the rainfall weight, we should multiply rainfall amount, which is equal to 5 inches, with the leachate production area, which is 1 yard square, and the density of water. In this equation, the value of density of water may come to you as an unfamiliar value because of the units used here, pounds per feet cube. And there are also other numbers in this equation, such as 12 inches per feet and 9 feet square per yard square. And again, they come from the unit conversion. And we can also calculate the final weight of lift with an additional solid waste, cover material, and the rainfall weights during the 1 year of operation. And after inserting our results into our sketch, and you can see them again in the left-hand side of the slide, we can continue to solve this question with step 2. In this step, we will write a water balance equation for the lift 1 at the end of the year 1 and calculate the leachate quality. And firstly, we should estimate the amount or weight of gas produced from the lift 1 during the year by multiplying the solid waste weight with the relevant ratio given in the question. Since this value is specified as 0 in the question, we end up with no gas produced at the end of the year 1. And therefore, water consumption to produce gas and the amount of water vapor found in the gas are equal to 0 because, there is no gas in the lift 1 at the end of the year 1. And then we should calculate the weight of water in the solid waste. And we have already calculated the moisture found in the solid waste structure itself, but after 1 year, because of the rainfall or infiltration of rain, 234 pounds of water is included into the solid waste, and the total weight of mass is 789.6 pounds. And then we should estimate the dry weight of solid waste remaining in the lift at the end of the 1 year. And normally, if we produce landfill gas, we will subtract this portion from the dry weight of solid waste. But in this case, since there is no gas production, the dry weight of solid waste doesn't change in this case. And in the next step, we will find the field capacity of solid waste, but to use this equation, we need an average weight on the waste placed in the lift. And please note that the average weight in the lift occurs at the midpoint of the waste in the lift. So after we add dry solid waste and the moisture waste together, we should multiply this number with 0.5 and include the weight of cover. And with this way, the average weight of waste is estimated as 3,172.6 pounds. And then if we put this value into the field capacity equation, that is also given in your lecture notes, we can find the field capacity as 0.4068. And the meaning of field capacity can be explained by the following calculation. And the field capacity is a quantity of water that can be held against the pull of gravity by cover material and the waste. And to find the water that can be held in the solid waste, the field capacity that we found just now has to be multiplied with the dry weight of solid. After this number is estimated as 1,038.9 pounds, we can realize that this amount is higher than the actual amount of water present in the waste. And actually, the negative sign given in the following equation means that. And therefore, it is concluded that there is no leachate formation in the lift 1 at the end of the year 1. So the amount of water remaining in the lift 1 doesn't change again. It is equal to 789.6 pounds. And moreover, total weight of lift 1 at the end of the year 1 is equal to, again, the summation of dry solid waste weight, all moisture content, and the cover material weight. And actually, this is the end of step 2. Up to now, we have made calculations for the lift 1 in the year 1. After the 1 year operation, lift 2 is added above the lift 1. And therefore, the previous calculation that we have done so far for the first year of lift 1 is valid for the lift 2 in year 2. Because, actually second year in the operation will be the first year for the lift 2. So we will not repeat the same calculation again. Actually, the dashed line above the first sketch for the lift 2 means that. As a third step, we will write a mass balance for the lift 1 at the end of the year 2 and calculate the leachate quantity. We will follow the same calculation procedure. And firstly, to find the amount of gas produced in the lift 1 during the second year, we should multiply the mass of solids with the produced gas amount or the volume at this year. That is also given in the question text. Then the produced gas weight is calculated 238.9 thousand by multiplying previously calculated gas volume with the specific weight of gas, which is equal to nearly 0.08 pounds per feet cubes. And at this point, also note that the weight of gas produced is included in the weight of solid waste that we use in this equation. Then we can calculate the required water amount to produce landfill gas by multiplying the gas volume with the ratio of water production, which is equal to 0.01 pound per feet cubes. Again, this ratio is given in the question. And therefore, the relevant water consumption value is calculated as 28.6 pounds. And then there is another portion that is found in gas as a water vapor, and we can find it with the similar procedure. Again, the relevant water vapor ratio in gas production is presented in the question text as 0.001 pounds per feet cubes. So, if you multiply this number with the volume of gas, we can estimate the water vapor found in the gas as 2.9 pounds. And now we should estimate the water amount in solid waste found in the lift 1 at the end of the year again. Normally we have 789.6 pounds water depending on the rainfall and the solid waste moisture content, but because of the water consumption and water vapor loss, now we have 758.1 pounds of water inside the lift 1 at the end of the year 2. And moreover, because of the gas production, the weight of dry solid waste decreases to the portion of the landfill gas. And it is concluded that the dry weight of solid waste equals to 1,983.3 pounds. And then again, to calculate the field capacity, we should find the average weight of lift based on the values that we have calculated before. Firstly, for the first lift, we should apply the same procedure. We should add the dry weight and moisture content of the solid waste and multiply that with 0.5. And then we should include the weight of cover material and the weight of lift 2. As I said before, lift 2 is above the lift 1, and therefore the pressure is applied to lift 1 because of the cover 1. And lift 2 at the end of the second year. And finally, we can calculate the average weight of waste as 7,715.8 pounds. And by using this value, we can estimate the field capacity as 0.36. And again, since this number represents a fraction of water in the waste based on the dry weight of waste, we can find the water amount held in the solid waste in the lift as 714.9 pounds by multiplying the field capacity with the dry weight of solid waste. And then by subtracting the water amount held in the solid waste from the actual water amount, we can calculate the formed leachate quantity. And in this case, since the water amount exceeds the capacity, we observe leachate production. And this amount is 43.23 pounds. If this much amount of water is formed leachate, then the remaining part stays in the lift 1 at the end of the year 2. And finally, by considering all estimated weight values and dry solid waste, moisture content of lift 1, total weight found in the lift 1 at the end of the second year is calculated as the summation of weights of dry solid waste, water remaining, and the cover materials. And you can see the relevant value in this slide. This is the end of recitation 8. Thank you for listening to me.